Assalamu alaikum. My name is Muhammad Umair Aslam and I am here to represent my topic for presentation, which is a question which will be solved using methods, LLP and with graphical representation. What is linear programming? Linear programming, often abbreviated as LLP, is a mathematical optimization technique used to determine the best outcome for a set of possible choices. In LLP, we aim to either maximize or minimize a linear objective function subject to a set of linear constraints. These constraints represent limitations or requirements imposed on decision variables. The goal is to find the values of decision variables that optimize an objective function while satisfying all constraints. The graphical method is a visual approach to solving linear programming problems. इसके अंदर हम लोग जो पॉइंट्स हमें मिलते हैं लीनियर प्रोग्रामिंग से, वी प्लॉट देम ऑन अ ग्राफ एंड विद दैट हम लोग जो एरिया अंडर कंसिडरेशन आता है उसके थ्रू हम मैक्सिमम वैल्यूज़ निकालते हैं और जनरेट करते हैं. So moving on to the question. The question is related to Ma and Pa grocery store. The question is that in the Ma and Pa grocery store, shelf space is limited and must be used effectively to increase profit. Two cereal items, Grano and Wheatie, compete for a total shelf space of 60 feet. A box of Grano occupies 2 feet and a box of Wheatie needs 4 feet. The maximum daily demands of Grano and Wheatie are 200 and 120 boxes. A box of Grano makes $1 in profit and a box of Wheatie makes $1.35 of profit. Ma and Pa thinks that because the unit profit of Wheatie is 35% higher than that of Grano, Wheatie should be allocated 35% more space than Grano, which amounts to allocating about 50% to Wheatie and 43% to Grano. What do you think? Moving on to the solution of this question. In this scenario, we are tasked with optimizing shelf space allocation for two types of cereal, Grano and Wheatie, at Ma and Pa grocery store. The store has limited shelf space totaling 60 feet and we need to decide how to distribute this space between the two cereals. So for this task हमने एक चार्ट बना लिया है जिसके अंदर हमने ग्रानो और वीटी की फीड कितनी जगह वो करता है और उन दोनों की डिमांड्स लिखती हैं और हमने प्रॉफिट लिख दिया है और उन सब के मैक्सिमम बॉक्सेस भी लिख दिए हैं कि कितने बॉक्सेस सेल होते हैं और फीड पे हमें कितनी फीड जो है हमें गिवन है मैक्सिमम, वो है 60 फीट. सो इसके थ्रू हम लोग एक चार्ट बना लेंगे और उसके बाद जो है हम मैक्सिमाइजेशन एंड कंस्ट्रेंट्स क्रिएट करेंगे. वी विल फर्स्ट ऑफ ऑल क्रिएट अ मैक्सिमाइज इक्वेशन यूजिंग प्रॉफिट एंड हमने जो है $1 और $1.35 जो था उसको हमने x1 एंड x2 के साथ रख के एक इक्वेशन बना ली है और उसके बाद हमने सब्जेक्ट 2 के अंदर जो इक्वेशन बनाई है वो हमने कितनी जगह ले रहा है उसके हिसाब से बनाई है 0.2 x1 0.2 x2 जो कि 60 से छोटा या उसके जितना होना चाहिए एंड वी कांट पास दैट वैल्यू ऑफ 60 बिकॉज उससे ज़्यादा हमारे पास जगह नहीं है. एंड मूविंग ऑन टू द कॉन्स्टेंट्स, हमने जो है x1 जो कि हमारा ग्रानो सीरियल है वो हमने 200 से कम या 200 तक रखना है बिकॉज दैट्स आवर मैक्सिमम वैल्यू. और जो है हमारा जो x2 है उसको हमने 120 के अंडर रखना है बट 0 से बड़ा रखना है. सो दीज आर द इक्वेशंस फॉर मैक्सिमाइज सब्जेक्ट टू एंड कॉन्स्टेंट्स. We can visualize the feasible solution space by considering the inequalities of the equation representing the total shelf space. We have put the whole maximized equation against 60, which is the total shelf space. When x1 is set to 0, we find that x2 equals to 150. Conversely, when x2 is set to 0, x1 equals 300. Now we have plotted all the values and drawn lines on the graph, and by examining the solution space we find that at point A we got 0 and 120, which represent it all of the space is allocated to Vt. At point B, all of the space is allocated to Grano, which says that we have point B values 200 and 0. At point C we got 0 and 0. At point D we got 200 and 0. And at point E we got similar situation as point C, in which we had x1 and x2 0. So we got the answer 0 0. And then all of the points we have gained from graphical representation, we put them in the maximum equation. So by plotting point A, which has 0 and 120, we get the maximum value 162, and from B, which has 60 and 120, we got the value 222. By plotting C, which has value 250, we got value 267.5, and plotting D, which has values 200 and 0, we got 200, and plotting E, which has value 0 0, we got 0. So the maximum we got is 267.5, which is at C 250. So this was the whole question.